Paired means t-test. We're going to address the research question, are scores on 2 quizzes different? Here we have data from 9 students. We have each student's score on quiz 1 and score on quiz 2. We're going to conduct a paired means t-test because data are paired by student and the variable of interest is quantitative. Step 1, check assumptions and write hypotheses. There are 2 assumptions of a paired means t-test. First, that the data are paired. For each student, we have their quiz 1 and quiz 2 score. The data are paired by student, so this assumption has been met. Second, in the population, the distribution of differences is normal. In this case, we don't know what the distribution of differences looks like in the population, but we can compute the differences for the sample and assess its normality. Here I have computed all of the differences. For each student, I took their quiz 1 score minus their quiz 2 score. For example, for the first student, 98 minus 94 gives them a difference score of 4. I used Minitab Express to make a histogram of these differences. The differences are approximately normally distributed in the sample, therefore this assumption has been met. Now we can write our hypotheses. Our research question was, are scores on the 2 quizzes different? This tells us that we're going to be doing a two-tailed or a non-directional test. I'm going to call the mean difference, or mu sub d, the mean of quiz 1 minus the mean of quiz 2. Our null hypothesis is that the mean difference equals 0. The alternative hypothesis is that the mean difference does not equal 0. Step 2, calculate test statistic. This is the formula that you're going to be using to compute the test statistic for dependent means. We can compare this to the formula for the test statistic for one group mean that you worked with last week. We can see that these are essentially the same formula. These formulas are the same as the formulas that you learned in Lesson 2 for the sample mean and the sample standard deviation, except now we have the subscript d to denote that you're working with differences as opposed to original observations. Let's start by computing the mean difference. Again, we've computed all the differences from when we checked the assumption of normality. The mean difference is equal to the sum of all the differences divided by the sample size. The sum of all of the differences equals 1. Therefore, the mean equals 1 divided by 9, or 0.111. Next, we're going to compute the squared deviation. We're going to take each difference minus the mean, that gives us our deviation, and then we're going to square it. Our sum of squared deviations equals 54.889. Given that the sum of squares is 54.889, we can use that to compute the sample standard deviation. The sample standard deviation is equal to the square root of the sum of squares divided by the sample size minus 1. Here, the standard deviation of the differences equals 2.619. We can use these values that we've computed to compute the test statistic for dependent means now. We have our sample mean of 1 over 9 and our sample standard deviation of 2.619. Our t-test statistic is 0.127. Step 3, determine p-value. We have our t-test statistic that we just computed. And from our original hypotheses, we know that we're doing a non-directional test. Degrees of freedom for a paired means t-test is the same as it was for a single sample t-test, the sample size minus 1. Note that the sample size is the number of pairs. In this case, we had 9 students, so the degrees of freedom equals 9 minus 1, or 8. Now we can go to Minitab Express to construct a probability distribution plot to determine our p-value. In Minitab Express, I'm going to construct a distribution plot to display probabilities. I have a t-distribution with 8 degrees of freedom, and t-test statistic, it's non-directional, of 0.127. In each tail, we have 0.451037. When we add these tails together, that will give us our p-value of approximately 0.902. Step 4, make a decision. We found our p-value to be 0.902. This is greater than the standard alpha level of 0.05. Therefore, we fail to reject the null hypothesis. Step 5, state your conclusion. There is not evidence that scores on the two quizzes are different.